Forces of evolution. The conditions for Hardy-Weinberg equilibrium are somewhat unlikely to be met in real-life populations. The Hardy-Weinberg theorem also tests populations in which allele frequencies are not changing. By definition, such populations are not evolving. How does the theorem help us understand evolution in the real world? From the theorem, we can tell that the kinds of factors that cause the allele frequencies to change. These factors are the forces of evolution. There are 4 forces, and they are mutation, gene flow, genetic drift, and natural selection.
Natural selection is a process by which some organisms have a greater chance of surviving and reproducing than others due to features better adapted to the environment. As a result, those advantageous features are passed on at a higher frequency than less advantageous traits. An example of natural selection would be where red bugs and green bugs are both in an environment. The birds prefer the taste of red bugs, so soon there are many green bugs and few red bugs. The green bugs reproduce and make more green bugs, and eventually there are no more red bugs.
Genetic drift is a random change in allele frequencies that occurs in a small population. When a small number of parents produce just a few offspring, allele frequencies in the offspring may differ, by chance, from allele frequencies in the parents. It's like tossing a coin. If you toss a coin just a few times, you may by chance get more or less than expected 50% heads or tails. In a smaller population, you may also, by slight chance, get a different allele frequency than expected in the next generation. In this way, allele frequencies may drift over time. There are 2 special conditions under which genetic drift occurs. They are called bottleneck effect and founder effect. Bottleneck effect occurs when the population suddenly gets much smaller. This might happen because of natural disasters such as a forest fire, by chance. Allele frequencies of the survivors may be different from those of the original population. Founder effect occurs when a few individuals start or found a new population by chance. Allele frequencies of the founders may be different from allele frequencies of the population they left. An example is described in the figure below.
Gene flow occurs when individuals move into or out of a population. If the rate of the migration is high, this can have a significant effect on alleles frequency. The allele frequencies of both populations they leave and the populations they enter may change. During the Vietnam War in 1960s and 1970s, many American servicemen had children with Vietnamese women. Most of the servicemen returned to the United States after the war. However, they left copies of their genes behind in their offspring. In this way, they changed the allele and frequency in the Vietnamese gene pool.
Mutation creates new genetic variation in a gene pool. It is how all new alleles first appear. In sexuality reproducing species, the mutation that matter for evolution are those that occur in gametes. Only those type of mutations can be passed to offspring. For any given gene, the chance of mutation occurring in a given gamete is very low. Thus, mutations alone do not have much effect on allele frequencies. However, mutations provide the genetic variation needed for other forces of evolution to occur.
Before we end the video, let's overview the main points of this film in a very short summary. There are 4 forces of evolution: mutation, gene flow, genetic drift, and natural selection. Mutation creates a genetic variation in a gene pool. Gene flow and genetic drift alter allele frequencies in a gene pool. Natural selection is a process where some organisms have a greater chance of survival and reproduction than others.